someone asking folks to come in.
Good afternoon and welcome to the campus of California State University, Long Beach. My name is Furuzan Golshani. I'm the Dean of the College of Engineering at this university, and it is my pleasure to welcome each and every one of you to this event. This is the third year of the Engineering Distinguished Lecture Series on this campus, and we owe this to the Dean's Advisory Council of the Engineering College and the initiative of the members of the Advisory Council that started this 3 years ago. And we are pleased that it is moving forward stronger than before. And with each lecture, we address one of the grand challenges that the National Academy of Engineering has identified for us to work on. So it's great to see you take an interest in this important topic, and again, it is all due to the work of a number of very distinguished individuals who have been working on this. Let me recognize the subcommittee of the Advisory Council that have put this lecture together. Kent Peterson is the chair of the committee. Mike Nigley, thank you, Mike, for starting this and continuing to help with this sustenance. Ms. Susan Fort O'Neill, thank you for your work and your leadership on the committee. Mr. Nick Ceramic, I don't see Nick in the audience, but he may join us later. And Mr. Dan Craig, I saw him, thank you. This is the committee that has worked to put together this lecture, and we are particularly grateful to the sponsors that made this possible for us. Many of these companies have supported previous lectures, and really these wouldn't have been, none of these would have been possible without their sponsorships. I'd like to acknowledge assistance and support from, financial support from Applied Medical, P2S Engineering Incorporated, the Port of Long Beach, San Diego Gas and Electric Pacific, San Diego Gas and Electric, Denso Sales, California Incorporated, Herzog Construction Corporation, the Boeing Company, Fort Design, and Technolink Association. Thank you very much. And with that, I'm pleased to introduce the moderator for today's lecture, Mr. Kent Peterson, to my right. Kent is the chief engineer and the owner of P2S Engineering, a local consulting engineering firm he founded some 20 years ago, along with his twin brother, Kevin. Hi, Kevin. He's a recent past president of ASHRAE, which is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. He's currently the president of the ASHRAE Associate Society Alliance, and in that capacity he works with 54 professional societies around the world. Locally, he's the president of the Long Beach Green Business Council and works very closely with the chamber. He has authored a number of articles and papers and has made presentations to government professionals throughout the world. He is a nationally distinguished lecturer on several topics, and I'm very pleased to say he holds a degree in mechanical engineering from Cal State Long Beach. Wonderful. And he serves on the Dean's Advisory Council, and thank you for that. With that, please welcome Kent Peterson.
Well, thank you, Dean Golshani. We've actually put together a fantastic panel this afternoon to talk about the smart grid and how smart it is. We all have smart devices. I mean, our lives have really changed in the last, I would say, 15 years. Not only with the age of computers, but cell phones, now smartphones. We're going to be talking about now not only the smart grid and how we connect all these devices together, but even maybe how we might integrate some of the devices we know as smart devices into the smart grid. Infrastructure is very important. It's important for engineering. It's important for us to be able to be where we're at as the United States and kind of leading the world in innovation. And certainly, if we look at our electrical infrastructure is in need of upgrade. And part of what we're going to be talking about today is that upgrade of the electrical infrastructure in the U.S. and using some of the smart technology and integrating that into the program. I also want to thank the sponsors for this event, just as the Dean did, because we are trying to really reach out to the community and provide to the local community, the alumni, the students, these free lectures where we can actually get these great speakers that volunteer their time to come here and talk on these topics that are of interest to the community and to the engineering community here around the campus. And that's a wonderful thing. And we'll continue to do it. I'll talk at the end of today about when our next lecture is scheduled. We've already scheduled that for the spring, and I'll give you those dates so you can mark that on your calendar. Without further ado, I'm going to introduce you to our first speaker. It's Lee Crevette. He's the Director of Smart Grid at the San Diego Gas and Electric. He leads the enterprise-wide Smart Grid strategy, policy, and project alignment for San Diego Gas and Electric. In 2010, he was actually named one of the top 100 movers and shakers who are influencing the smart grid market by Green Tech Media, and was recently elected to the Board of Directors of Gridwise Alliance, a smart grid advocacy coalition with the mission to transform the electric grid to achieve a sustainable energy future through the advocacy of well-reasoned smart grid policies at the federal, state, and local levels. Let's welcome Lee Crevette.
All right, thank you very much. Hey, thank you for having me. It's a pleasure to be here. And I wanted to start off with a quick story about my daughter. She called me up a couple weeks ago. She and a friend had seen a play at school, and she wanted me to pick her up. So I hopped in my Nissan Leaf, which is an all-electric vehicle. There's no gasoline, no tailpipe. So I got in that car, and I went and I picked her up, and she and her friend got in. And when they got in, the friend said to my daughter, "What kind of car is this? It looks all weird." And my daughter started to explaining to her how it didn't have a tailpipe, it ran only on electricity. We didn't have to stop at gas stations. And her friend was blown away by it. She said, "This is amazing. I have to get my dad to buy one of these." So my daughter said, "Well, why would your dad buy it?" And he goes, "Well, he's putting solar up on the house. He's comparing prices. He's put solar up." And they spent the 15-minute ride back to the house, each talking about solar and electric vehicles and the future and the environment. I thought, oh my God, this is really what my business has become. It's about making sure that the electric infrastructure in the country, in the world, now, even though I only have San Diego as where I focus, moves forward so that it can support those new products that our future generations, and a lot of you are in this room, are going to need in order to have the environment that we all deserve. And really, based on prices on these kind of technologies, now that we're on the technology curve, they're going to be coming down to where the grid is going to be seeing a lot of this, and it's very new. It's something that the grid wasn't designed for, so it's something that we're going to need to figure out. So let me start talking about what is a smart grid, just to give you an overview. First, out of Wikipedia, and I will say if you go to Wikipedia now, you won't see this definition because various vendors have gone in and changed it to reflect their products, the kind of things they're interested in. If you go back 3 years to what the definition is, you can find this one. And by the way, my kids told me, "Dad, if you want to tell people what it is, just go to Wikipedia." And smart grid is really about leveraging technology and the improvements in technology in order to make the grid be better. When I say be better, be more efficient, be more safe, be more reliable, incorporate the new technologies that are out there. So one fact that not a lot of people know, and it blew me away when I found it out, is that in 1980, for example, the average home had 3 to 5 energy devices on it any one time, and now that number is about 25. And so people are very dependent on electricity now, and now that all these changes, when I say changes, an electric vehicle is like plugging in a house into the grid, wherever it happens to be. So that's a lot, especially when you have more people that are purchasing them and plugging them in. If you put solar on your rooftop, suddenly you're not just a consumer of electricity, you're a producer. So you're a prosumer, is the term we're using. And sometimes you're putting electricity on the grid, sometimes a whole neighborhood has solar on it, That's a lot of excess energy, and the grid really wasn't designed for that. When 1 or 2 homes had that, it was not a big deal. Now that we have thousands of homes, in San Diego, in California, almost 100,000 homes. That's a lot of homes that are now producing energy, a lot of two-way flow. So the drivers and why Smart Grid has really something we're really focusing on now, and I'll work my way from the bottom up. Years ago, when we talked about Smart Grid, it was how can we leverage technology to improve the grid, to make it more efficient, to make it more reliable, to make it more safe, very grid focused. But a few years ago, with a lot of the environmental laws that passed, a lot of the incentives around renewable products, it became apparent that we had a new challenge, and that was in order to support those environmental policies, to invest money in the grid in order so that it can take on the new challenges, the environmental policies. So bringing it solar, fuel cells, wind energy, all of which we don't really control, the utility doesn't control. For 100 years, the utility had the switch, they could dial it more and less, and suddenly Mother Nature controlled the dial. They could give you more or less energy, and we had to figure out how to keep the grid in balance, given that we didn't control the generation. And then lastly, and I have it on top because it's last but certainly not least, is the customer. Over the last 2 or 3 years, we've seen a new product, smart meters, which give the utility and the customer the capability to see how much energy they're using, not at the end of the month when it's too late to do anything about it. At the end of the month, what can you really know about why your bill is what it was? But suddenly you're able to see the bill. In San Diego Gas and Electric, you can come onto our website and see what you used every hour. And you can look at that the next day, so you can think about the day before and how you might adjust your behavior. And in our pilots, our customers are doing that. They are adjusting their usage based on what, now they understand when they're using energy and figuring out what that's about. So that's very exciting. Now, I did have customer there and of course environment and grid, but really they're all about the customer. So having the grid be more efficient, reliable is about the customer. The environment is about our customers. It's just that the last one is directly facing the customer. So suddenly we're really having a conversation with our customers about energy usage, and that's very new, having that dialogue. So I'm going to talk about 4 specific topics in these areas. The first is customer empowerment, providing that data and devices so the customer can have some control over their energy management. The second is centralized renewables. So think of big wind farms, you see all the windmills, or big solar farms producing a lot of energy, and then using transmission to bring it into where people are using electricity. Distributed renewables, specifically solar, so that would be rooftop panels on commercial industrial buildings or on people's homes, and electric vehicles. With regards to smart meters and the consumer, we've now basically finished our deployment in San Diego, about 98% complete. And so our customers are now able to go online and see how much energy they've used and make decisions based on that. Let me see. We have, when we first started deploying the meters, we wanted our customers to have that data immediately, but we didn't really have the tools yet. So we made a deal with Google, where if a customer came on our website and authorized us, we would each day send their usage data to Google anonymously. So in other words, no personal information, and Google would reattach it to that customer's account, and they'd be able to see their usage very early on when we started deploying these meters. Now Google feels they've done their job. They've actually stopped supporting their tool, figuring it's successful because other companies have come into that market, and we've also replaced that tool. So on our website, you can now do that without the Google Power Meter. What this picture shows, and it didn't translate very well from a font perspective, but the various parts of the home that are going to be connected. So in the meter, there's a technology called Zigbee, which is a wireless technology that allows the meter to send signals about what's going on from an electric point of view into your home. Your appliances can or cannot react. These smart appliances that are coming out, thermostats, refrigerators. So for example, a thermostat, if it gets a signal that prices are going up because it's a very hot day and energy is very expensive, could make it so the air conditioner didn't come on until 75 degrees instead of 72 degrees. And therefore, because we have the smart meters, we can measure you use less energy, and we're actually giving rebates based on energy reduction on those types of days, as an example. GE has a refrigerator. that when it gets that signal, depending on how you set it, again, we're just saying the price went up, right? If you set the refrigerator in the right way, it will stop making ice. It won't defrost during those time periods. It'll wait for nighttime to do that. So just some examples about how it's all tied together. You, the customer, doesn't have to do anything. The appliances react to the knowledge that's out there. The next thing I wanted to talk about was distributed renewables. This is just a graph that shows on our residential rooftops the kind of growth we're seeing in photovoltaics or solar. And it's really tremendous. If you look at the growth that we've had in 2011, it's even more, the growth is even more than in 2010, so that chart would go through the roof. And there are forecasts that the California Energy Commission makes. This year, we're exceeding that forecast by 76%. It's almost twice the predicted adoption of solar. So it's really tremendous. And you might say, well, why do you need a smart grid for that? So I wanted to show this slide. This data came from a sensor on one of our circuits, one of our lines, that has a lot of homes that have solar on it. So it has a very high percentage of solar penetration. We have about 20 of those circuits out of about 1,000 circuits that have that kind of penetration. And this shows the voltage swinging. So the top graph is over a few hours, and the bottom graph is just 10 minutes from the top graph, where the rectangle is blown up. And as you can see, the power engineers in the audience, this is really bad. You don't want your voltage swinging like that. It's actually out of compliance. So at the end of 2009, we had about 6 circuits like that, then 12. Now we're over 20 circuits like that. So the more solar is adopted, I'm going to come back to my kids. It's a great thing. I mean, that is what's going to happen. Prices are coming down. People are more aware of the importance of the environment. But we do have to figure out a way to manage this, and that's where the smart grid comes in. Once it measures signals like this, to do something about it, to ensure the voltage, to ensure the power quality is good. I want to go back a slide. I also talked about centralized renewables. So what this shows is our mix of energy and where we get it in 2010. So you can see there's a small sliver 4 up. It's like aqua, that's coal. You can see that in 2015 there's none. In 2020 there's none. You also see solar. There's none as of 2010, but in 2015, it's the third one up. You can see that it starts to be significant. In 2020, very significant. People say, why just 12%? Because that's about what it is. If you think about it, solar can only produce energy about 1/4 of the time, when the sun is shining brightly in the sky. And so for it to average over the course of a year, which is what this talks about, over the course of a year average, for it to average 12, that means when it's actually making energy 1/4 the time approximately, it has to be making 50% of the energy. So there'll be times during the day when just the energy that's in large solar farms will be half. And then a large percentage will be wind. And then you'll have the rooftop solar. The reason I mention this is because Mother Nature will be controlling the majority of the energy on our grid. And our job will be to react to what's going on with wind and the sun and clouds to ensure a consistent power quality for our customers. So it's going to get a lot more difficult here as we move forward. And if you look at the 2015, that's right around the corner. In terms of technology, we're going to be here very soon. I wanted to spend a little bit of time talking about electric vehicles, another of the major drivers. This is a graph of where the electric vehicles are in San Diego. If I were to have shown you a graph in November, it would be blank. If I were to show it to you in December of last year, it would have 1 dot on it. 1 electric leaf was delivered. Maybe 2, I think 1 volt was delivered. And then a few for the first 3 months. Really, the deliveries didn't start until the end of March. So if you think about how many EVs, those are the green dots and the blue dots on there and the yellow dots, it's a lot. We're actually over 800 now, and we're talking about just a little over 6-7 months of these vehicles being available. Just a tremendous amount. The purple dots are solar, so you can see that they're clustered in certain areas of our service territory. And the overlap between the electric vehicles and solar is 1/3. So 1 of every 3 electric vehicles is bought by a customer that also has solar. So it's another interesting dynamic that sometimes they're feeding the grid energy when the sun is shining and they're not home, but then if they plug in, they're suddenly a big user of electricity. So it's very hard to manage a system with that lack of predictability to it as to what's going to happen. I talked before about electric vehicle being like a house with the air conditioning on. That's a big thing for us, and here's why. We tend to design our systems for the number of homes that's going to be off a certain transformer, and we size it so we're not wasting a lot of money to really match what we expect that home to have in it. Well, on our coast of San Diego, we didn't assume people would have air conditioning because they didn't have air conditioning back then, but the home values have gone up a lot. And so a lot of them have gone out and retrofitted and now have air conditioning, so that ups the load based on what we originally designed the system for. And now maybe the average in San Diego is 6 to 8 homes per transformer. So now you're plugging in these cars that are each a house with the air conditioner on. So if that happens at night, if you look at the bottom graph, our system can handle that. That's okay. We're not too worried about it. But when people get home from work, which is that top graph, that shows when people tend to get home from work, and if they were to plug in right then, when it's most convenient, they enter their garage and start charging right then you end up with the situation on the right graph, which really brings a new peak to the system. So in essence, we would have to build new generation and new wires to deal with that new load. So it's very important that, from a smart grid perspective, that we manage the grid so that we don't create that. So we both incent our customers with rates, but we also need to measure what's actually going on so that, for instance, we measure when people are actually using energy so we can build them differently. So right now we have, for electric vehicles, they pay a lot less if they charge at midnight. I always charge at midnight. Luckily, the Leaf has a timer in it. I set it for midnight. I plug it in when I come home, but it's smart. It doesn't start charging until rates go down. And then real quickly, I'll wrap up in a couple of slides here by talking about our deployment plan. In California, there was a bill, Senate Bill 17, that required each of the big 3 utilities, the IOUs, that's our own utilities, to file deployment plans by July 1st. So we filed ours. It really asked us to talk about the future and what we intended to do to support all of this, because everybody, if you look at the data, you know that this is coming, just from the policies of California, the prices of these technologies. So they wanted us to be ready, and they really required that we have a vision of the future, that we talk about a baseline, where we are today, and then our strategy from getting from our baseline to our vision. So what is our strategy to get there? How are we going to make sure it's secure? And then a roadmap of the various projects we were going to do to get us there, to get more specific, and then costs and benefits of each of those projects, and then metrics to measure how we're doing. So we filed that back in June. Really focusing, we had some interesting focus areas. One is we wanted to focus on our community. We didn't want it to be just about SDG&E building a plan that only we understood and only we cared about and no one else knew what we were doing. So we went out to our customers and to other interested parties, politicians, universities, and started talking about these issues and asking for feedback. What do they think we should do? And really tried to have a plan that was more of a community plan instead of just a plan from the utility. And we took a ton of that feedback and put it in the plan. Also, it would have been really easy for like 5 smart people or people that think they're smart to get in a room and just write the plan and say, okay, great, we wrote the plan. But that really wouldn't change the culture of the company, because you only have a few people who understood what you were talking about. So instead, each area of the company, we call it a domain, each of the domains within the company, each wrote their own plans, and they got in a room together and workshopped all their own plans. They had to present them, take feedback, to merge them all together. We ended up with about 200 people in the company that really all worked on putting this plan together, making sure the plan was integrated and that everybody was bought into and committed to moving forward the same way. And I should also mention that we had the way utility usually measures benefits is kind of things I talked about, efficiency and reliability and safety. But we took on a new challenge, and that is to look at it more from a customer's perspective, which maybe we should have been doing all along. But it was another way to look at it. And so if you make the data available to your customers, they can see how much they're using. For example, there's a benefit to our customers of that. It might not be more efficient for us, but it's more efficient for them, so they can reduce their costs. So we factored in that benefit as well, and we also factored in environmental benefits. If we ensure that electric vehicles are on the road successfully, we make sure that they're not causing outages. If we make sure more solar can be installed, and that's going to reduce the amount of carbon, and that has a value to society. So we started valuing that as well. I'll speak. How much time do I have? I have a minute, okay. So we had 9 different program areas, which I've listed here, where the projects kind of funnel under. Customer empowerment, renewable growth, electric vehicles, security. I've talked about a few of these areas. For each one of these, we have a roadmap. So we talk about all our projects, how they fit in together, where in the process we are of doing those projects. We really did that so that our customers will understand what we're doing, so vendors will understand what we're doing, so they can sell stuff to us. All interested parties would know where we're going and can comment on it. We're actually in a comment period now at the commission where people can talk about their opinion about it. Renewable growth, the projects we're doing so that we continue to grow with renewables. And electric vehicle growth. There's 9 of these roadmaps, so I just wanted to give you an example of what they look like. Anyway, thank you very much for listening to me. I hope that was a good overview of smart grid.
Well, thank you, Lee. Our next speaker is Brad Gammons, and Brad is the Vice President of Sales and Solutions for IBM Global Energy and Utilities. By far, I think Brad made the longest commute for the lecture tonight. He came from Beijing, and he's currently on assignment in Beijing, China, where he's been for the last couple of years, where he's serving as Vice President for IBM's Global Energy and Utility Industry and Vice President of IBM Greater China Group Energy and Utilities. During his 20 years at IBM, Brad has held numerous positions designing and delivering solutions for IBM clients. He serves on the board of the Center for Commercialization of Electric Technology in Texas. He co-chairs the Smart Grid Working Group of the U.S.-China Energy Cooperation Program, and he has testified in front of the U.S. Congress on energy issues and been featured in articles in Forbes and Business Week. Let's please welcome Brad Gammons.
So first, I'm very happy to be here and have a chance to visit with you for a few minutes. So something meaningful is happening. I'm going to come up a level to maybe a little bit more macroeconomics and trends that are driving why an IBM is talking about smart grid, why Boeing is sitting on a panel, why POSCO, the largest steel manufacturer in the world in Korea, is talking about smart grids, why Samsung is. Why is it a topic that so many large companies that weren't traditionally doing business with San Diego Gas and Electric in this kind of space, why are they standing here? And there really are some meaningful things happening. Well, one might be that you got up this morning, right? Individually, that may have been the big event today. You may have asked someone to marry you. You may have got your first job offer or an internship, started a new business. So there are a lot of things that are meaningful to us. But one thing for sure is the way you do everything in your life has changed substantially in the last 15 or 20 years, 30 years. When I was in school and studying, I did my work on a slide rule. When I was looking at fuel for a B-52 and how much we had left, I did it on a whiz wheel. It was kind of a round thing that you went like this with on. I remember dial telephones and what that was like. And it's really hard for me to imagine what 30 years has been like and the change that has occurred then. In that period of time, the world has changed substantially. And you can look around this room and just see that looking around the room if you look right and left right now. We live in a global economy, one that is highly connected, highly competitive, where information flows freely. That's occurred in the last 20 years. And what that has done, fundamentally, is changed the way the whole world is developing. Because the world that is developing right now is smarter. Smart grid is only one small piece of what's gotten smarter in that period of time. How we apply that smart and make something intelligent is going to be the real determining factor of quality of life, competitiveness of economies, competitiveness of businesses. What do we do with that thought and how do we apply that in a global economy that's highly competitive? Also, we just peaked over 7 billion people running around the world. That's a lot of folks. So the world that's growing economically, this year 150 million people move into cities in China from the countryside that will now consume energy that didn't consume much energy before. 20 villages in West Africa will see a light bulb for the first time as Africa enters the world economy because of investments from emerging economies like China and Brazil. They're making massive investments in Africa. And so when you start hearing about new emerging economies in the next 5 years or 6 years, where you've listened to India and China and Brazil and Asia, ASEAN, you're going to start hearing about Africa and another very large population that's coming online. So the idea of how you support all these people with rising economic abilities and do that sustainably is a big question. So the smart grid becomes unbelievably important because we can't use and distribute energy the same way we did before. And that's important because this isn't just about regulatory policy in California and interested in being green. It's really about how we use resources in the long term in a much larger population that has a much higher quality of living that's using energy more than ever before. It's maybe 21 energy devices here. If it was China 10 years ago, it would be lucky if it's one. Now you've got 100 million electric bikes plugged in charging their batteries every night and has an air conditioner for the first time. So a very, very different world. In 2008, IBM launched something called Smarter Planet. And I picked some slides out from some predictions our chairman made in 2008 to make some points. And by the way, we have a brand new chairman as of 2 days ago, Jenny Rometty, so our first female CEO, and we're very proud of that and very excited about her appointment as CEO of our company. But these are, and she actually can talk about smart grid, which even makes it better. We talked about a smarter planet starting in about 2008. It was this idea that everything is intelligent. So, you know, the beginning question is the smart grid getting smarter every day? Absolutely. There's nothing that's made today that doesn't have intelligence in it. It's getting instrumented. If it's a transformer, it's got a sensor on it now that'll say oil temperature, vibration. A lot of new facts are associated with it. I've got sensor on power lines. I've got sensors sitting in the substation. I'm collecting more data than ever. So the world's getting instrumented, but you can have a lot of smarts, just like you can have a lot of smart people being in the room and have absolutely no intelligence. And we've all been in rooms like that, and we've all participated in many PowerPoint presentations where we know that's the truth. So what we've looked at as a company is how do you take all the instrumentation that's being created and how do you begin integrating that? And we have the ability now, right? That's what the telecommunication revolution was about, and the internet, and it's what Tom Friedman talked about in The World Becoming Flat, this idea that we can connect everything together, and we started by connecting people together. That's what it was about at first, right? Optimizing the way people work together, information-based businesses. The next revolution we see, the Boeing see, and all these other companies, is a revolution in connecting the physical world to us, so that the physical world and the information world integrate. You know, in engineering terms, the operational world meets the enterprise world, right? OT and IT merge. And just think of the implication as an engineering student sitting here, or someone that is running an engineering firm or working in a company, of merging two worlds that have been separate for most of history. Is IT is all set in its world. OT had IT in it without a doubt, but they sat in separate places, so the two worlds are coming together. So instrumented I talked about, these are just some funny little facts. 1 billion transistors for each person on the planet. There is not a moment in your life anymore where you're not on video, being sensed, watched, touched in some way about your day. It's amazing what the Department of Homeland Security knows about you. And Boeing could tell you all about that probably. A little bit of IBM. We're interconnected. We're always tethered. Right? And what you're hearing here today is you're going to be tethered to the smart grid. You're going to be a component of the way energy demand is managed by how you're connected to this and how you get pricing signals, demand signals, and incentives to do something different. You're going to be interconnected. The big question is, are we going to be intelligent? In other words, are we going to take this huge capital investment that's being made by governments around the world, and are we going to do something with it to shift the way we live, the way we work, the way we use resources? That's the big open question, and that's going to come down to how do I take all the data and how do I do it something meaningful in the way I change something I do, the way I manage the environment in this room, the way I decide to move students in and out of classrooms at what time of day, many different things will change based on how we use information to shift what we do, modify what we do to have better economic outcomes, social, and environmental. So we have an opportunity to think and act in new ways. Something we talk a lot about internally to get this intelligence is something called systems thinking. We can't think in silos any longer. If you just look at Lee's charts, you're talking about homes, you're talking about a grid, you're talking about power plants, you're talking about governments. All those things have to interrelate with each other and play off of each other to get the huge benefits. Information has to be shared, and it has to apply back to the infrastructure that's being used. So in engineering fields, this is a huge area, is how are things going to interrelate? You no longer will be able to sit in one silo. It's how do things play together using the information out of each of the systems and create integrated systems that have different outcomes. The only point I want to make out of this slide is it's always good to look a little bit at history and how things change. As we've watched what's happened from the telephone to phone to wireless and the amount of change that's brought. But if you think about the most fundamental changes that we've had in the industrial period of time, it's been when fuel has changed, the way we use energy. And you can watch history as it's gone through, and we went from oats to coal to oil. We're getting ready to switch the energy we use. It's going to make fundamental changes to every balance sheet and the way we do things and the way we live over the next 20, 30 years as we go through this transition. And it's going to happen faster than ever before. That's that last curve. The innovation curve around that is steep, and economies and governments around the world are going to be made or broken based on how well they address this transition. And I can tell you, we're not exactly in the lead here in the U.S. And one testament is I'm sitting in Beijing doing a headquarters job. I'm not doing it in the U.S. This is what's happening to the grid. Is we've gone from something, coming from an IT world, think of the major trend that's going on, is remember the mainframe? And you had one green screen, much the young kids that go, what is a mainframe? But at any rate, it's the idea that information came from one place and you got what you got. And it came down one central line. Think of all the change we've gone through in the IT industry, going to distributed, to client-server, to distributed, to cloud. That's what's happening in the energy world. Think of all the technology, all the processes, all the security, everything that had to happen for that to happen in the IT world. Same thing's going to happen in the energy world. It's an exciting time. If you're here as an engineering student, I'll put my plug in. We need you. I can't find enough engineers. I can't fill my quota. So you're in the right place. Study hard. For those that are students in the room, there's a job waiting for you. Thank you.
Well, thank you, Brad. It's always nice to know that there's engineering jobs out there for those that are in the engineering department. I can guarantee you when you look at the statistics around the world right now, engineering is one area, even in this recession, that you can find a job in. Our next speaker is actually Chuck Prescott. He's a program manager with Boeing Energy, the Boeing company. And in 2010, he actually became the program manager for Boeing Company's Smart Grid project with Southern California Edison. As a leader for emerging clean tech business at Boeing, he's responsible for transitioning capabilities developed for the Department of Defense into the utility domain. So it's going to be interesting to hear what he has to say about developing things that are actually used in the military and then implementing it into our smart grid. He leads a team of systems engineers and software engineers, integrating a military-tested and cyber-secure service bus with legacy utility applications and emergent distribution system applications for the Irvine Smart Grid demonstration. Please welcome Chuck Prescott.
Can you guys hear me okay? All right. Yeah, I'm going to come down here and kind of get comfortable. Yeah, so thank you, everybody. It's my pleasure to be here with the distinguished speakers and guests here today, so thank you so much for having us here. Lee and Brad, you set me up really good. I appreciate that because I think you really set the stage for this huge transformation that we're seeing in front of us. I mean, this is something that you're not going to experience again for your lifetime. And so you just need to take a second and appreciate that and realize how big of a change this industry is going through right now. You know, in aviation, the aviation industry went through a huge transformation with the jet age. And that jet age transformation took probably from the 1960s until the mid-70s for it really to take foothold. And I'm going to suggest to you today that this technology is going to take some time to change, and you might guess decades. Some people may want to have it quicker, but it is a huge transformation that we're going through. So, let's see, that'll work. Okay, so I suspect that nearly everyone in the room knows who the Boeing company is, so I don't need to spend a lot of time with that. But I do want you to understand that the Boeing company really is a technology company. From our highest leaders down to the engineers on the floor, we are really our focus on technology and how to develop technology and deploy it in the field. Many of you may be aware that we just had our first commercial flight for the 787. That flight went from Narita to Hong Kong. It's the first composite aircraft with 20% improvement in fuel efficiency, and it's going to change the way that airlines make money in the aviation business. What I'd like to bring to you today is a little bit of information on the commercial side, but really focus on what we're doing on the defense side and how we're taking technology from investments from the DoD and hoping to leverage it into the utility domain. So the commercial business, we have about 12,000 aircraft out in the fleet. It's 3/4 of the fleet out in the world. So we really have a good installed base and really understand how to operate that network of aircraft. And with a 787, it's a wired aircraft. It's a sensor. It's bringing back more information than any other airplane we've ever had before. And we're learning how to integrate that network of information so that airlines can make intelligent decisions on the way they operate. I'm on the defense side. The defense side is about the same size from a revenue standpoint as our commercial business, although next year commercial is expected to have a pretty good spurt of growth, maybe 30%. But really where we come from is, and the area that I'm most focused on is really on the net-centric operations and how people are networking systems together. Brad talked about systems and complex systems, and that's really where Boeing has its strength, is when you have to have large-scale systems integrated. You probably know Boeing, we do sell commercial or military platforms also. The C-17, built and delivered out of Long Beach Airport, just up the street here, near and dear to my heart because my wife works on that program. And every time I see a C-17 flying into Long Beach Airport, I see a paycheck coming home. So that's great. So Boeing is, what I'd like to share with you today is how Boeing is leveraging our DoD investments on net-centric systems and bringing that into the utility domain. And where we're focused right now really is on DoD microgrids. So there are military bases in Southern California, like Marine Corps Air Station Miramar, or like Camp Pendleton. And these bases are concerned about energy surety. To them, it's critical that they have power when they need power to execute their mission. And so we're thinking about ways how we can help them with technology. So how did we get here to this point where we want to help protect and connect people and our DoD installation customers? Well, I'd like to just kind of walk you through a quick synopsis of our technology heritage. And I know I don't have a lot of time, so I'm not going to read through every bit and piece of this chart. But a lot of people ask me, why is Boeing in energy? How did that happen? Well, we've been doing it for quite some time. Since the energy crisis in the 70s, we've been investing in energy. In the late 70s, early 80s, we were working small solar thermal and large solar thermal projects up to the 10 megawatt scale, and working with partners like Southern California Edison and others at that time. You may have seen in the previous chart that we do satellites. Our satellites have photovoltaics on them. And as the satellites got larger and larger, there was more and more demand for more efficient photovoltaics. So our subsidiary that we own, SpectroLab in Sylmar, California, actually holds the world's record for the most efficient solar cell, 39.8%. And we are the supplier of 80% of all the concentrated photovoltaics in the world. We're a merchant supplier to other vendors that integrate it into their products. So we really do have a keen understanding of CPV and PV technologies and been working it for some time. We also know a little bit about aerodynamics, and we know a little bit about composites. And so that brought us into some NASA contracts and some DOE contracts that we did in the 80s and 90s on wind turbines. And so we developed a pretty good technology there and had some very large diameter wind turbines up for that time, quite sizable, and actually sold off that technology to Vestas, and that helped Vestas get to where they are today. We also have been active in fuels, and I'm not going to go through all the details, but just be assured that we are flight testing in C-17s and 747s biofuels that can power airplanes in the future as that network and as that supply chain gets developed. We've also done supervisory control and data acquisition systems, or SCADAs. Actually delivered some of those systems to people like Con Ed in New York City, Bonneville Power, Salt River Project, guys like that. And the thing that we're really focused on today is really on the interoperability piece of software. And so there's been huge investments by the DoD that Boeing has led projects on, hundreds of millions of dollars, for interoperable operational service buses that are secure and can operate in I'll say a distributed environment. And that's really important to the DoD, but as you look at the grid, it's very interesting because the grid is I'll say a dynamic network where you have people buying EVs, popping on the grid, putting solar on the roof, popping in the grid, and it's a dynamic network. And there's a real desire to have a secure network. And so as you bring these things together, you can take technologies where we've tied together DoD legacy systems with new applications they want to plug in and make them interoperable. And it's a very nice way to move forward to advance that technology from the DoD into the utility domain. We've also done quite a bit in terms of cybersecurity from an acquisition standpoint, and picked up a handful of companies like Autometrics, Exmeritus, and Norris. And these companies have helped us provide I'll say a layered cybersecurity defense system. In the military, we call it defense in depth, where we're not just depending on one firewall to secure the system. We have a multitude of security systems that lay on top of each other, sort of like peeling an onion in a security sense. So that's kind of our right to do business, if you will, in terms of a technology standpoint and what allows us to enter into this space. And I told you earlier that we're looking towards moving into DoD microgrids to help them out with those types of command and control systems. The way that we view that space from a modernization standpoint is going through a number of different evolutions. Some of these are occurring before our eyes. The reduced demand piece, I think we've seen quite a bit of work done with the energy service companies, with lighting projects and HVAC projects, and things like that to reduce demand on the grid. The next phase that we see are things like local generation and local storage capabilities. And so we see, we heard Lee talk about photovoltaics went up on roofs in San Diego, and storage systems starting to come into play into people's businesses and homes. EV infrastructure coming into place, and people talking about how do you use vehicle to grid energy and vice versa. But now where we're starting to see the opportunity for technology at Boeing really is in the advanced controls area. And so now it's time to take these individual components and network them together into a smart, complex system. And that's where the strength of Boeing really comes into play. What we see the ability to do is to bring some of these systems into play to securely connect distributed energy resources and manage the critical loads, let's say on a DoD base, with the local generation. Or dynamically control, say, a demand response event. Instead of just shutting off the air conditioning when you have a DR event, now you might say, okay, let's power up our fuel cell, or let's bring online our storage. And you really have the ability to let that smart system optimize to whatever your objective function may be. Do you want to minimize your cost? Do you want to minimize your carbon footprint? Do you want to have the best reliability in your system? or some blend of those things. And so the smart system now gives you the ability to manage all those assets as you go forward. The last phase that we see is grid independence. Now, when you have an event, you can gracefully transition off the grid onto your local microgrid and manage yourself in a secure fashion. And to the DoD, that's really important because now they're able to continue on with their critical missions. So, so really, I guess what I'd like to leave with you is that we're now to a point at Boeing where we'd like to be able to take these advanced networks and smart controllers to the DoD, prove them out, and I think the next step really is once that technology is matured in the military arena, that the domain for the utilities now is an open space. And I think that the potential is there for us in the future to bring these things that are developed in a military installation to a smaller microgrid, maybe in a commercial community. Thank you very much.
Well, thank you, Chuck. Our last speaker this afternoon is Joe Data. He's the Chief Executive Officer for Smart Labs Incorporated. Now, me being an engineering graduate, an engineer most of my career, I'm a technical geek. And I can tell you that it's kind of interesting. Joe Data is the Chief Executive Officer of Smart Labs, and they actually produce devices that allow you to control just about everything in your homes. And so as we've been talking about the smart grid, he's going to give us a perspective today a little bit more about how we might actually integrate some of these smart homes and smart devices we have with the smart grid in order to start managing things a little bit better. He founded Smart Labs in 1992 as a bootstrap startup. He had a vision that our homes should have remote control everything. Shortly thereafter, he co-founded and launched smarthome.com, becoming one of the world's first e-commerce companies. During the late 1990s, he acquired two product engineering firms, formed Smart Labs Design, and began designing and manufacturing proprietary remote control, lighting, and related products for our homes. Please welcome Joe Data.
Note to self, if you want to feel important, you don't follow IBM and Boeing on a panel. Jeez. Next time, Kent. First. Well, as Kent mentioned, we make all kinds of remote control and automation products. We are on the other side of the meter from SDG&E. So we make thermostats and light switches and pool pump controllers, et cetera, et cetera. Our position in this market is to help load shed if necessary, but I view it as load leveling more than load shedding. As maybe not clear yet, HVAC is probably the #1 place where people think about load shedding. As somebody who's done a lot of field testing, I can tell you that as the heat on those days where there are DR events gets high, people really appreciate if you can find other ways to save energy. If they start feeling a little uncomfortable. HVAC, heating, ventilation, and air conditioning. So basically your thermostat. Pool pumps are, especially in this economy, are something that very low impact to you personally if the power company or yourself choose to turn that off during a peak load. And these peaks are very regional. While we have peaks here in the middle of the afternoon in Europe, and in the middle afternoon in the summer in Europe, it's completely different, so it's pretty interesting. I think you've seen pictures up here, but you basically, anything that draws power in the home that you can turn off during a peak event helps the system. We learned something important, something surprising in our first smart grid test about 5 years ago. Consumers are willing to load shed just to feel as good citizens. So one of the utilities we were working with had us install switches that blinked the LEDs on them when they were into or heading into a higher usage time period, and without any motivation, without any rate-based change, people would start turning things off because they either wanted to feel good about the way they were living their lives and or prevent being turned off completely. And they saw up to a 14% decrease in power use during those time periods. It was pretty darn surprising. We can skip this. Insteon is a technology that we use, again, on the other side of the meter in the home. And I'm proud to be here with one of your alumni, Dan Craig, who is really the architect behind Insteon. It's a very, very exciting wireless plus power line technology that simultaneously communicates over those two physical layers. Like Zigbee and Z-Wave, it's a mesh network where every node is a repeater. But we have the ability to work around problems on the power line. If there's something attenuating the power line, it can jump up to RF and around it. Likewise, if you have a big stainless steel door on a fridge or something like that, it can use a power line to get around those problems. One of the things that's very, very surprising is the way that the signal propagates. Most networks use a network routing table. We use what we call simulcast, where every node will repeat every signal simultaneously, creating a resonance, a harmonic harmony, kind of like musicians in a symphony. And then finally, something that we've learned after 19 years of being in this business is products do take a long time to get into the market. They're out there for a long time. You want to make sure that the product that you install today will work with tomorrow's technology. And we use a kind of like a radio station button in your car. You press and hold, it memorizes the setting. It doesn't need to know that it's a country station or a rock station. The problem with a lot of networking technologies in the home is they're not forward compatible, and when a controller comes on the market and needs to say, give a certain command to a responder, that responder needs to be able to speak the new language. So it's a very, very novel technology that one of your alums has created, and I think he's living testimony that you can do great things.
Actually, to have the speakers tee up the topic. And we now have approximately 20 minutes that we're going to leave it open for a roundtable discussion. We do have a speaker or a microphone up here in the front, and I would ask that if you would like to ask a question, please come to the microphone, identify yourself, and please ask your question.
Good afternoon, gentlemen, and thank you very much for this wonderful topic and distinguished guest. My question is from Lee. How do you see the evolution in this smart grid technology leading to open the market to other players rather than being exclusively provided electricity service by the existing utility companies? Or
Yeah, I think it already is. In San Diego a few years ago, maybe we had 0.1% of our customers that generated their own electricity. Now we're probably at 1.1, going 1.2% in just a couple of years. And the way that it's growing, that number is going to be very significant by 2020, without a doubt. And there are other providers coming in and selling those solar panels.
But not on a direct basis, but on a commercial basis, meaning other provider of the electricity working along with the utility companies.
But we have that as well. Most of the power that we deliver to our customers is generated by somebody else. And we procure that on behalf of our customers. The main part that's ours are the wires, and that's probably not very efficient to have multiple sets of wires going into a home. But the other pieces of the ecosystem, I would say, are changing. So you have other people generating on their own, and thus procuring that power. You also have some people with direct access, so they're procuring their own power. And then you're having people entering the market with devices to control the energy. Also, there's a technology was mentioned briefly, we didn't talk a lot about it, called a fuel cell. So you can use natural gas today to create your own electricity. We have a number of customers. Our customers are doing that as well. Now they still use the grid because they don't produce exactly how much they need. So they still need to be attached. There's also a future of batteries, should they come or when they come lower in price, of potentially managing without being attached to the grid. And I think all those things are coming. And a lot of them are already here today, and you can see that by the growth.
Thanks. And do you still see the incentives hold next year, as this year? The federal incentives and all these other incentives for solar energy, would they?
So I think incentives will evolve as the technology matures. We're already seeing prices come down to the point where they will continue to grow without the same level of incentives, and they probably should come down commensurate with the cost of the product coming down.
Thank you very much.
How you all doing? I don't know who will answer this. I'm interested in that second part of the title. How smart is it? I don't know if you can give us that idea. And how smart will it become, I guess, is another question. I'll throw this out here too. We're talking about technology and technology innovation that's going to continue. And I'm just wondering if this does evolve, will manufacturing occur here in this country? It's a lot, so I don't know. Maybe I'll grab it.
Do you want to give them an idea who you are?
Oh, I'm dean of the business school here at Michael Salt.
So the grid's never been dumb, so that's first. So it's been getting smart for a long time.
Let's talk in the microphone. Yeah.
The grid's never been dumb, so it's been getting smart for a long time, and it's extremely smart. I think the question is how automated does it get based on the intelligence that is available, and so how much automation needs to be done. And that varies by part of the world and when they built it. So if you're sitting in a brand new city in China, the level of automation and intelligence is much higher than if you're retrofitting an existing system. So I think the intelligence is already at a very high level. How you apply it based on all the factors Lee talked about is the next challenge, is how do you apply that intelligence to manage it when you have all kinds of variable energy sources coming in, and how you go about doing that and to develop equipment around it is a huge area of investment. The battery technologies, the inverters that have to be developed for that, the changes in circuits and switches, and a lot of that development investment is mostly outside the United States, in Germany or in Korea or Japan or China. So heavily outside except for GE left here in the U.S. Most of it's done outside, and the great deal of the renewable technology is also developed outside the United States right now.
I think if we can kind of remove the stuff between the generators and the utilities and the consumer, it'll get extremely efficient. So right now, I run a facility. I can't see what the facility's using. I'm judged, or we're billed on peak rates. And while I hear that there are places you can go see these things, I don't have visibility to it. If the rates, if these utilities could charge the rates, cost basis, and then the consumers would make all the right decisions. Consumers are just exceptionally smart with their wallet. And so that's what we hope this is all moving towards, is real-time pricing, and then consumers know how to do that. And I think that it'll get smart fast if that happens.
So I just want to say that it's not just so consumers are very smart; they will make the wise choice, but people aren't going to shut their TV off in the middle of a television show. So it really comes down to the systems that you're talking about that do that automatically. We are testing systems now, and they work, that go into different modes depending on cost. So you buy that product because you know it'll save you money. You don't then have to switch it on and off. And I think I think it's going to become very smart. And I think that it'll be somewhat siloed at first. So with each product will know what it wants to do. But over time, things in the house, for example, will be like an orchestra and use more and less to keep loads at a more constant level, for example. Again, based on price, based on environmental impact, whatever that consumer, that customer is interested in.
I just want to address two things. First, how smart is it going to get? Well, it's going to come down to what makes economic sense. So I mean, we can design, and Boeing's really good at this, we can design really smart stuff, but nobody can afford it. So the trick is going to be, right, I mean, the consumer won't pay the kind of price that would cost for a concentrated photovoltaic on a 702 satellite in space down in the terrestrial space. So it's as smart as the consumer's willing to pay for ultimately. The other thing is I'm not ready to throw in the towel on technology in the U.S. I recognize that China is a manufacturing center of the world, and I'm not saying that Boeing can compete with production of PV. And I don't think we're interested in trying to compete with that because it's probably a losing proposition. But what we can do is we can find where we have our sweet spots, and we still have strength in technology that's been developed, perhaps in the DoD space, perhaps in other spaces. And I would put it forward to this room of folks here today that we can leverage where we have strengths, and we can move forward on those areas.
Thank you, Dr. Salt.
Mike Niggler with San Diego Gas and Electric. Throughout the world, we see so many different protocols, practices, procedures, regulations, standards everywhere. Do you see any extraordinarily major hurdles in terms of your businesses because things are so fragmented? Or is this something that we can overcome, but it's just going to cost us a lot of money? And sort of to what extent do you really think we should have additional standardization within countries and around the world?
We won't invest until there's standards, or we'll invest a lot less until there's an emerging standard that we know we can glob onto, because you can't get scale without that. So we spend an enormous amount of time trying to influence standards around the world. I think this industry has actually made a lot of good strides the last 20 years through the IEC and standards that are coming out for the smart grid. I think the engineering profession can help drive that through the IEEE. I think is doing a good job, but for it to grow and for the businesses around it to grow, the home devices, the things in the substation, standards are critical. And the other thing is that with standards, it allows you to get to economies of scale in your manufacturing a lot quicker if you're not doing to 4 or 5 different standards out there. So I think it's exceptionally important for that, although there are a lot of incentives to not put standards in because that allows you to lock in technology bases and client bases. But I think even more, Mike, than the engineering standards and technology standards, regulatory issues in this industry also are huge barriers for companies investing because there's no certainty in what kind of spending utilities around the world or energy companies are going to be able to have, because regulatory policy, energy policies in flux, that's another huge inhibitor to investments by commercial companies in this area.
I'd like to briefly talk about a good example and a bad example, so I'll start with the bad one so I can end on a good one. We're at SDG&E, we're in the middle of our rate case right now where we say this is how much money we need. Generally we do that every 3 to 5 years. That's a multi-year legal case. So when you talk about technology and having to so legal right away means adversaries. So people are on different sides. And most of that debate, is written and then some oral, but it's not people collaborating and coming together. But from a technology perspective, when you're trying to adapt technology, that's an incredible complexity. It takes a lot of time, and technology moves a lot faster than that. So that's something that has to really change in order to support decisions, people coming together at a much quicker rate if we're going to move at a technology pace. On the good side, we are working right now on something called the green button. So it's a button that it will not only be on our website, it will be on PG&E's, it will be on Southern California Edison's. The Chief Technology Officer of the country, Anita Chopra, came to us and said, look, there's an evolving standard for how you would put customer data out there, usage data, pricing data. Why don't you guys just do it? You already have the smart meters out there. And so we got together and we said we're going to do it, and that's going to happen in a matter of months. Where we said that sounds like the right thing to do. It isn't very expensive, and because it's a standard, anybody that wants to build a tool to look at that data and help one of our customers analyze that data, they know what the standard is. So you could have 20 companies each trying to develop a better tool, and again, that opens up a whole new market that isn't the utilities market. We're just providing the customer with their data.
think Mr. Gibbons mentioned that the energy management in China is different than the United States. I was wondering if you could elaborate on how is it different, and are they investing in different technologies or different processes? I mean, more.
Part of it is it just gets mandated. So it kind of simplifies the whole thing a little bit because it's centrally planned. So, but they don't have unending energy, and they've got environmental issues. So they're having to look at how they shift for them, small percentage, but it's actually a lot, to renewable energy and use demand management. So for those, as talked to engineering here, is their focus on building automation and energy efficient with buildings is very high. And architectural firms from all over the world are helping them develop the next generation of buildings, and they're building a lot, right? So they just have that opportunity, and the government's forcing that into the standards of what's being done. And the same goes with renewable energy. So it's really, you could call it public-private, it's really not, but there's just a great emphasis on sustainability and clean tech, both because of environmental issues in China, national security, because they don't have a lot of natural resources, oil, coal, those kind of things they purchase from the outside. So that's driving their behavior. And then economic development. They see clean technology as a major economic driver. In other words, lead in wind turbines, lead in solar technology, lead in facilities control systems. So they're on a high ramp curve, again, linking government to business to own those next generations. And their 12 5-year plan that they just announced, it's one of their focus things for the next 5 years, and that plan is developing a leadership position in clean technology. I totally agree that the Western world can compete and go right at it, but there's some advantages to a centrally planned, basically business, so you call it government or business, driving those kind of missions forward. And so it's different in that manner.
Is there an emerging environmental consciousness in China? Because generally we think of them as not being very environmental conscious.
I mean, in the educated and middle class, absolutely. And so there really is, because most of their education is in the Western U.S. I mean, that's the university system of choice is here in the U.S. And you've got the internet. So the internet is crammed on their version of Twitter and Facebook. All of those are there. And that is there's high consciousness in that class, which is still hundreds of millions of people. But you still have a mass of people that aren't conscious of that at all, but that's administered through policy.
And you mentioned that China's taking their path towards sustainability is two ways. You said energy efficiency through their buildings and also through renewables.
Right.
And I was wondering which one has greater emphasis and which one is more viable, do you think, in the United States?
I think what they're doing is viable everywhere in the world, right? In buildings, we have some of the leading energy efficient buildings and green technologies here in the U.S. They're fast followers with a lot of the technology that they're using is being developed here, and then being, what do you want to call it, brought to scale in China. It's just
big scale.
In big scale and that. So they're doing both. There's a heavy emphasis. Just an interesting thing. Mayors in China all run off the same balanced scorecard. And so you can almost look like it from a business school, the way you look at a balanced scorecard. You could be the mayor of Shanghai and 2 months later be running China Mobile. And so they have a common scorecard that they move between. So cities compete, and they actually have KPIs on energy efficiency within the cities and the amount of green energy they're using. And so think of it as them all being executives competing for how they did against their scorecard to move up in the central government. So that puts a heavy emphasis on performance within the cities to innovate, look outside for technology, because they're competing with each other. And so they look to IBM, they look to Boeing, every name brand you can think of corporate international companies there, Siemens, ABB, Ariba, and we're all partnering with these many businesses that are cities, to be honest.
I might add just a little bit on that on the building side. Buildings in the U.S. use 40% of our primary energy. the largest consumer of all energy in the United States. So it's pretty common around the world that buildings use most of the energy in most countries. And we have a lot we can do here in the United States. The studies that have been done, even in California, which I say California and New York really lead the nation as far as energy efficient building policy starting back in 1975. California has a goal right now to go to net zero energy residential construction by 2020 and net zero energy commercial construction by 2030. Most of that will be done through energy efficiency, but you can only get so efficient. You still have to consume energy, and that's where the renewables will come in. So economics will play an important aspect in that, and trying to balance out if I can get more bang for my buck on saving the energy and whether it's retrofitting an existing building or building a new building, do that and then put the least amount of renewables in order to get to that balance.
You asked it as an or, this or that, and it's really and.
Yes.
It's take advantage of everything you can.
Recently, the Secretary of Education, he kind of downplayed solar energy as a renewable source, and I was wondering what you guys thought of that. I mean, do you guys agree with? Have you guys heard that? Do you guys agree with that?
I didn't hear that. The Secretary of Energy,
Yes.
Chu, Dr. Chu.
Yes.
If Dr. Chu actually said that, it was probably in the context of looking at what renewable energy from photovoltaics is doing, solar energy is doing in the U.S. as a whole right now. And it's a very small fraction when you look at it. And some of that has to do with the fact of what Lee had talked about and saying you're only generating about 1/4 of the time. And the other times you're not generating. So when you look at the big picture, it doesn't have a big picture. I mean, when you look at the overall energy supply, I think in the U.S. and the solutions we're looking for going forward, it's a blend of a lot of different technologies. There's no question it's not just going to be solar, it's not going to be just nuclear, but I think nuclear has a part in all this.
So I've heard him speak, and I understand when I've heard him speak, he's been incredibly pro-solar.
Oh,
And the cost of solar, I think the administration has said would be around $1 installed per watt by 2020, which would change everything. You'd still have to figure out a way when there's no sun. So whether that's storage or whether it's other forms, but that at that price, that would be a pretty popular way of generating energy.
Yeah, I'd have to agree that there's a need for a blend of distributed energy resources, and so the kind of blends that we've been seeing people interested in include solar, microturbines, storage of several technologies, of course wind, although DoD installations aren't so keen on wind near runways. But I do think that solar is going to have a place for a long time. I just don't see it diminishing.
Growing.
Yeah.
It'll be growing.
Yeah.
Thank you. We have time for two more questions.
I have a small technical questions about smart grid. Move forward a
A little closer to the microphone, yes, please.
I have a technical question on the smart grid. Suppose we have two houses using same energy efficient appliances, and we have installed the instrument that takes the data from that takes controls from the grids and the local supply, whether it is say solar panel or whatever. Is it possible that two houses takes the grids online same time and it doesn't functions the way it should be designed, like for say something is still it is grading, like say everybody is using power at the same time, and this system is also using the grading system at the same time. The reason I'm asking this question is, suppose I'm working in a big complex that has a different plants. They are utilizing the power, and that power is being grid with say government power supply systems. So if one power trips, it has a separate grids. The another power trips, and it gets effect the same with the another complex. So how it will work actually? Logically, I mean, when everybody is using the power at the same time and it is switching at the same time. So what ultimately how it will work?
Is it a reliability question?
No. Yeah, I'm asking, suppose everybody is using these things. And as per like say, this system is used because a lot of power consumption at a time creates problems. So it is switching over.
I'm going to give this a try, and I'm trying to interpret what I think you're asking, and that is that it's a pretty complex system. You have generation like solar coming in growing amounts, also a lot of appliances, electric vehicles, it's a very complex system. And how is that going to work? Is that a reasonable paraphrase?
Yeah, I mean the function of that instrument will fulfill the gridding function, because see, the smart grid is to change the power from whatever the local available to the supplied power, the switching.
If I'm switching between my local panel here, I was on and off grid, going between the two imbalances.
But the two things are going simultaneously with the same consumption.
Right. So a couple of answers, because so one concept that we hit on very briefly, I think Jacques hit on it briefly, was the idea of a microgrid, and we're building one in San Diego, considering others. And the idea of a microgrid is that it can connect and disconnect from the grid depending on grid conditions. So if the grid were to have an outage, a microgrid would be able to handle that transition, and depending on the technology used, could potentially do that without even a momentary outage, maybe by leveraging battery storage to pick up the load. And also combining that maybe with some demand response to lower the amount of the load, and leveraging any generation that is local that happens to be off to back up the battery as the battery runs out of energy. It's kind of complex. It's a very complex project. It's funded by the DOE a few years ago with a grant given to SDG&E, and so we are working on that right now, trying to figure that out. There is software out there to help us do that, to manage that transition, to reconnect, to disconnect, and then reconnect, which is also quite an issue, it turns out. So that microgrid technology, you talked about it from a military perspective. We think it has applications. For instance, we're looking at new neighborhoods that are being built, new communities. We're talking about putting that technology in those communities over time so that they wouldn't be dependent on the grid. And I think your point about where you get your energy from, we imagine that the microgrid will also be able to optimize for cost and environmental impact, so that if costs are very high on the grid, it would leverage more of what it generates itself, and if prices were very cheap on the grid, it wouldn't do its own thing, it would just get it from the grid. But that technology is evolving, and a lot of parts of the world are working on it.
Thank you. One more question.
How you guys doing? Noel, electrical engineering. Okay, I had a lot of questions, but this is a question for everybody. How do you foresee smart grids taking over regular grids that we have now?
He's looking at me. And Brad got into it quite a bit. I think that it's not a separate grid. The smart grid is leveraging technology to make the grid that we have reliable, more efficient, more safe, given the changes that are happening, given the aging of the grid, so that we don't have to build a whole new grid, and instead leverage technology so that we can have the grid that we currently have continue to serve us. It's not a separate grid, it's making the grid we have smarter by leveraging technology.
When governments around the world talk about smart grid, usually they're talking about some energy infrastructure that's more flexible in the way renewable sources are brought in. You can do your self-generation, you can do integrated electric vehicles. So usually smart grid is a euphemism for a different kind of energy ecosystem that this grid will enable, because the grid itself, the utilities have been investing consistently for a reliable electric system. That's why your lights are always on. The real question now with smart grid is, I'm changing that energy ecosystem substantively in the way power comes in, and a smart grid will allow for that. that kind of flexibility, and that's the next level of investment that utilities all around the world will need consumers to support, because to do what Lee just described is not a small investment in infrastructure to allow that. And so there's going to be big decisions made by governments around the world and basically consumers of how bad you want that, because it costs more in your rate.
Thank you. Let me have the right to ask the last question. You know, with the smart devices and the smart meters, and there's so many just here in California that are being installed, I think, Brad, your slide actually said it fairly well. I mean, there's so much data collection occurring. I guess my question would be, do we have the technology to actually transmit all that data, or are we only transmitting part of the data? Because certainly when we want to start using all the data that's available in those meters or other parts of the grid, we need the capability, I think, to get all that data to some location.
This is like your baby.
Or is this part of the evolution?
We're not a telecommunication company. What I can tell you is the innovations by companies in mesh radio networks at the local level and the amount of data it can carry has advanced enormously in the last 5 years. What you can do over power line carrier and broadband carrying within a building to transmit reliable information, huge advancements. That's, you know, if you look at the investments that Juniper, Cisco, and those companies are making, the advancements in 4th generation, you know, WiMAX and Wi-Fi is, I don't see pipes as the problem anymore. You have a problem with economics, like you mentioned earlier, of how much data you need against the investment in the communication network. But the technology itself has advanced to a point where you can move massive amounts of data. And now what I call low latency networks that are closer to devices can really move at a sub-second, millisecond for real-time kind of management. So that technology is there. The real barrier for everybody is sifting through the data quick enough to make real-time decisions in a control room or feed it back to the consumer to make a decision in the home. So that's the next wave coming, is the management of the data and then simplifying that into actionable signals, you know, to the market or to a control center, whatever it happens to be.
The way we're seeing the system design is not all back at one data center. Okay. There'll be computing happening at substations closer to where the decisions need to be made, when they can be made, closer to where the decisions need to be made, when it needs a bigger view, then we'll pass data back for coordination maybe between different circuits. But if it's a circuit issue, then that should be determined very locally by the systems there.
Excellent. Well, this concludes our speakers and the roundtable discussion. I would like to actually point out the fact that we are proud to announce that we have a distinguished lecture website on the College of Engineering website. It's up here. It's also in your program with the link of where the lectures will actually be posted. You'll actually probably see all of the presentations posted on that website by next week for this presentation, but you'll also find any of the previous presentations, including the one on sustainability, the California Water Challenge, and our last one on cybersecurity. So if you happen to miss one of those presentations, you can go back and actually see the video and also look at the slide decks that were in those presentations. I'd like to thank everyone for attending. I'd also like to once again thank our great panel of speakers today. And I'm sure if you had a question that couldn't get asked, I'm sure they'll stay here for a few minutes to be able to answer those questions. I'd like to turn it back over to Dean Golshani.
Thank you for an informative and thought-provoking set of presentations, and appreciate the time you took to join us today. Obviously, the grid is smart, and it is getting smarter. I just had heard a remark back there saying, well, make it smart, but don't ever shut down my TV in the middle of Dancing with Stars. So that is where we draw the line. So thank you. There are little gifts that I'm pleased to present to you on behalf of our school. Ken, thank you. Oh, thank you. Let me see how I can't carry more than. Okay. Lee, thank you very much.
Thank you very much. Thank you.
as Kent mentioned, the next lecture would be in spring. The date is April 26, and I'm sure the organizing committee would be pleased to hear any thoughts you have on the topic of it. As I mentioned, the topics that they have chosen up until now very much is the list of the challenges that the National Academy of Engineering has identified. Healthcare is probably next on the list, health informatics, better medicine, individualized medicine. These are things that engineers can contribute quite substantially. Education, and generally making better technology for advancing science. These are some of the topics that they are considering, but they'll welcome any comments you may have. Thank you all for attending, and once again, thank you to the organizing committee and the sponsors who made this possible. Thank you.
Great job.